prime, which, and psi prime is the result of replacing, oh, there is again a typo here. So let me correct that. It should be V of P square brackets psi prime. Okay. And that's what we wanted to prove. We wanted to show that's the claim above. If we are assuming V of psi is equal to V of psi prime, and we want to show that V of phi with psi is the same as V of phi with psi prime. But in this case, phi is just the letter P, and then P of psi is just psi, and P of psi prime is just psi prime. So that takes care of the first case, the base case. Now let's look at the induction step. So the first induction step is that phi is a negation. Let's say that phi is not theta. Well, first you have to realize one thing about this notation. So and what you have to realize is this thing, this thing here. If you take the formula not theta and replace occurrences of P in it by psi, you get a new formula. But that's exactly the same as what you obtain if you start instead with theta and replace all occurrences of P in theta by psi, and then put a negation in front. So on the left-hand side here, we have the whole negated formula, and we have replaced occurrences by P in it by psi. On the right-hand side, we have replaced occurrences of P by psi in theta, and then we have put a negation in front. So I hope you see that this is two different procedures, so to speak. But it should also be clear that the result is the same. The result is exactly the same. And that's what we can use when we now do some calculation. So here is the calculation. Let's see. We start with V of not theta square brackets psi. Okay, this is equal to 1 if and only if. Now we use this fact that I just mentioned. It's if and only if V of not theta square brackets psi equals 1, because those are the same formulas. But this formula is a negation. And when is a negation true? Well, it's true if and only if the unnegated formula is false. So that's the truth definition, right? Now we just applied the truth definition. But now we have a simpler formula without the negation, and we have an induction hypothesis, namely, we've already proved the claim for the simpler formula. So this has value 0 if and only if theta square brackets psi prime has value 0. This is the induction hypothesis that we're using here. And this is the whole crux of proofs like this. The induction hypothesis is that the formula, the claim already holds for less complex formulas. So we're trying to prove it for a negated formula, not theta. And we use the fact, we assume that it's already clear for the unnegated formula, which is simpler in the sense, it's simpler in the sense that it contains one connective less, right? So the step from the last step we took here using the induction hypothesis is the crucial one. And then we can go on, because now we use the truth definition again, which says that this is holds if and only if the value of not theta square brackets psi prime is 1. So this is again the truth definition. And finally, we use the fact about replacement that we already noticed. So this is the same as not theta square brackets psi prime. And this is what we wanted. We wanted to show that V of phi square bracket psi is the same as V of phi square brackets psi prime. In this case, phi is not theta. It's a negation, it's not theta. So we want to show that V of not theta square brackets phi has the same value as V of not theta square brackets psi prime. But the values are 1 and 0 and nothing else. So we have shown that the first formula has the value 1, if and only if the second formula has the value 1, which means that the first formula has the value 0, if and only if the second has the value 0. So they have the same value. And that takes care of this induction step. But we're not done, because that was just negations. Now we want to do conjunction and disjunction and so on. Let's just do one more case, namely this case is then that phi is conjunction, theta 1 and theta 2. And now again we have to note something. Sorry. What we need to observe is this, right? So if you take theta 1 and theta 2 and replace the occurrences of P in there by psi, that's the same as replacing the occurrences of P in theta 1 by psi, and then conjunction, and then replacing the occurrences of P in theta 2 by psi. So now you see there was a point in not requiring that there actually are occurrences of P, because it could be that P occurs in the conjunction theta 1 and theta 2, but perhaps it occurs only in theta 2. But I still want to know what theta 1 square brackets psi is. In that case, if there is no occurrence of P there, then that's just the same as theta 1. But I just want the notation to cover that case too. Okay, so we're observing this, and then we can just calculate again as we did before. So let me do the calculation on the whiteboard or on this slide here. So we have V of theta 1 and theta 2 square brackets psi equals 1 if and only if. And now I use this fact that this is the same as v of theta 1 square brackets psi and theta 2 square brackets psi equals 1. But this is a conjunction, so I use the truth definition. When is a conjunction true? Well, if both the conjuncts are true, so I can write it like this: v of theta 1 square brackets psi is equal to v of theta 2 square brackets psi is equal to 1. But then I use the induction hypothesis, which is that the claim is already clear for the simpler formulas theta 1 and theta 2. So this is the same as v of theta 1 square brackets psi prime equals v of theta 2 square brackets psi prime equals 1. So that's again the induction hypothesis. And then we just go on with the truth definition. That's the same as the conjunction being true. Okay, and by this fact that we just noted, this just merely syntactic fact, that's the same as theta 1 and theta 2 square brackets psi prime being true. So you see it's very similar, but you see that the formula is actually a conjunction. Then you apply the induction hypothesis to the conjuncts, and then you go back again. Okay, so that is an example of an inductive proof, and you will see many such examples, but I wanted to give you one that was not completely obvious, but although the fact itself should be, the replacement fact should be clear. Okay, so I think we're supposed to end more or less right now, but this is our first class, and I would really like your feedback on this class. And I mean feedback now on not just the logical part, the text, but also the quality of the communication. If you think, for example, I have shown you a number of slides and I have been drawing on the slides. Is that a good idea? Should there be more writing on the whiteboard by me and less pre-written text, or the other way around? Things like that. Suggestions that you might have to improve the quality of this format for lectures, because it's really is the first time I'm doing this, and probably the first time maybe the first time you are doing this too, and any kind of suggestions for improvements are welcome. So maybe not now, because now we should stop, but let's use WeChat or email or but preferably WeChat for any comments or suggestions about the format, but also, of course, about the content that we have talked about today.